Okay, hello and welcome back. In this video, we're covering section 12.2 on arithmetic sequences. So this is a special class of sequences that have particular patterns and properties that we'll explore in this video. Okay, let's first define what an arithmetic sequence is. So in general, an arithmetic sequence is one where the difference between two consecutive terms is always some constant number, which we'll denote as d. Meaning to get from one term to the other, you just add the same number or subtract if that number is negative. So we have our example we've seen in our previous video a lot, the first n natural numbers. So 1, 2, 3, 4, all the way up until n. So we can say the common difference here, d, would be 1, because you would just add 1 to get to the next term. And our first term is 1, so we could define these recursively by saying a sub n should just be your previous term, a sub n minus 1 plus 1. Another example would be the sequence 3, 6, 9, 12. Every time you go to the next term, we're adding 3 to the previous term. So the common difference, d, is 3. Our first term is also 3. So we could say recursively, the nth term should be your previous term plus 3. So in general, if we want to define an arithmetic sequence recursively, you'll start by listing the first term. You can find out what this common difference is by taking a sub n and subtracting a sub n minus 1. So if you subtract two successive terms and you get some constant difference, that'll be d. So we can say our first term is just a, and a sub n is the previous term plus the common difference d. So in example 2, they start by first asking us to show that this is an arithmetic sequence. They want us to find the first term and the common difference. So they have s sub n defined as 3n plus 5. So if we want to find the common difference, we can think just generally to take s sub n and subtract s sub n minus 1. We know what s sub n is. It's 3n plus 5. S sub n minus 1, well, we would just plug in n minus 1 for n. So 3 times n minus 1 plus 5. So let's subtract these and see if we get just some constant number. That would tell us that our sequence is arithmetic. The difference between two consecutive terms is a constant. So we'll do 3n plus 5, that's s sub n, minus 3 times n plus 1 plus 5. That's our n minus 1 term. Oh, and this should be minus here, not plus. Okay, let's simplify this and see what we get. This would be 3n plus 5 minus, it looks like that will be 3n minus 3 plus 5. So 3n plus 5 minus 3n plus 2. So distributing the negative, 3n plus 5 minus 3n minus 2. Notice the 3 n's will cancel, and we just get positive 3. This is going to be our common difference. If the n did not cancel, that would mean that we don't have an arithmetic sequence. The difference is not just some constant term. So we have our common difference d, and let's also list our first term. Let's find s sub 1. That would be 3 times 1 plus 5. So positive 8. So our first term is 8, and our common difference is 3. So let's do the same for example 3. This time our sequence is t sub n, which is equal to 4 minus n. So let's find the first term first this time. Let's find t sub 1. That will be 4 minus 1, which is 3. And now let's see if we have a constant difference between successive terms. So let's find t sub n minus t sub n minus 1. And that will be our d value. So t sub n is 4 minus n minus t sub n minus 1 would be 4 minus n minus 1. So just got to be careful with distributing these negatives. So this will be 4 minus n minus 4 minus n plus 1, distributing the negative to both terms, so 5 minus n. So 4 minus n minus 5 plus n. Our n's will cancel, and we get that our common difference is negative 1. So that means to get to the next term, you just subtract 1 every time. So that's how we can tell if a sequence is arithmetic or not, given just the general nth term definition. But let's develop, instead of a recursive formula, just a general formula for the nth term of an arithmetic sequence. So let's build up to a general term. Our sequence would start with just some a1 value. Then we're saying we'll have some common difference between every successive term. So that means our second term should be our first term plus that common difference. Our third term, recursively, we would say, well, that would be our previous term plus the common difference again. But a sub 2 is equal to a sub 1 plus d. So we would add another d to that. So really what we have is our first term plus 2 of the common differences. Hopefully that makes sense. Add one d, add another d to get to our third term. And in each term we're just adding another d. So that means a sub 4 should be our first term plus 3 common differences. Our fifth term would be our first term plus 4 of the common differences. So notice this number is n minus 1. If n is 5, we add 4 common differences. So let's say in general, this pattern continues. So a sub n will equal our first term plus n minus 1 times the common difference. And that's going to be the nth term of an arithmetic sequence. So if we know the first term and the common difference, we can list any point in the sequence that we want to. So let's practice. And they have this stated from the text. For an arithmetic sequence a sub n, whose first term is a sub 1, and whose common difference is d, the nth term is defined by this formula. So let's look at number 4. We want to find the 41st term of this arithmetic sequence, and they don't give us the recursive definition or anything, they just list the sequence. So 2, 6, 10, 14, 18. It looks like each term they're adding 4. So let's list our first term. A sub 1 is 2. And then our common difference is 4. So since we just said formula for the nth term is our first term plus n minus 1 times the common difference. Let's find the 41st term. That would be a sub 41. So that will be our first term, 2, plus n minus 1. N is 41, so it'll be 2 plus 40 times the common difference of 4. So 2 plus 40 times 4, that will give us 162. So instead of having to list out all 41 terms, we can just jump straight to the 41st term. In example 5, we have a similar question but with different starting information. This time they tell us the 8th term is equal to 75 and the 20th term is equal to 39. So we know two different terms, they're not next to each other, so we can't tell the common difference. But let's see how we can find out, one, what the first term and the common difference are, and then what a recursive formula in the nth term of the sequence would be. So we're given that a sub 8 is 75 and a sub 20 is 39. So let's use two statements from our general nth term formula, and I'll write it out again here. A sub n is equal to a sub 1 plus n minus 1 times d. So a sub 8 should be our first term, which we don't know yet. So a sub 1 plus n minus 1, in this case that would be 7, times our common difference d. And this is equal to 75. Let's do the same for a sub 20. We still don't know the first term. This would be n minus 1, so 19d. And this is equal to 39. So we have essentially two equations with two unknowns. We can solve this like a system of equations. So let's write these out again. So we can solve this either by substitution or elimination. Looks like it'd be pretty easy if we just subtract the second equation. We'll eliminate our a sub 1 and be able to solve for d. So if we subtract these, the a sub 1 values will cancel. Then we'll have 7d minus 19d, which will be minus 12d. And then 75 minus 39 is 36. So it looks like d is equal to negative 3 if you divide the negative 12 over. So that's one piece that we need. Now let's plug this back into one of the original equations to solve for our first term. So I'll plug into the first one. So a sub 1 plus 7d equals 75. So let's plug in negative 3 for d. So that gives us a sub 1 minus 21 equals 75. So add the 21 over, and our first term we get is 96. So this is a decreasing sequence. It's going to decrease by 3 every time from a starting value of 96. So part B asked for a recursive formula. So with a recursive formula, we want to list our first value. And then we can say in general, a sub n would be our previous term, a sub n minus 1, plus the common difference. In this case, it's a negative common difference, so we can write it as subtracting 3. And then our nth term, a sub n, should be our first term, 96, plus n minus 1 times the common difference of negative 3. So we can actually multiply this out and simplify it a little bit. We have 96 minus 3n plus 3. So in general, we can say 99 minus 3n. So we have some formulas we can use for the sum of an arithmetic sequence, where if we have the sum of the first n terms, we have a formula that will all add up to n over 2 times a sub 1 plus a sub n. And we call this the sum of the first n terms. The notation that we'll use is s sub n, but we could also use summation notation as well. So two different ways of saying the same thing, that we're going to add up the first n terms. So just be k from 1 to n of a sub k. So let's use this formula. I won't go through the derivation here. It's a fun exercise to try to produce this formula. If you're into that sort of thing, you can start here and try to express this in a way and work with it so that you can end up with this general formula. So let's just work on using this in context. In example 6, we're asked to find, in general, the sum of the first n terms of this sequence. So we have 8 plus 11 plus 14 plus 17, and this will continue. So it looks like 3 is the difference between each successive term. So we can say our first term is 8, our common difference is 3. So we have our first term. What we're going to use is s sub n will be equal to n over 2 times a sub 1 plus a sub n. So we have our first term, we just need the nth term. And based on our previous work, that should be our first term plus n minus 1 times the common difference. So we know our first term and our common difference, so let's plug that in. That will be 8 plus n minus 1 times 3. And if we simplify that a bit, that's 8 plus 3n minus 3, so 5 plus 3n. So let's plug all that in. Our general formula for the sum of the first n terms would be n over 2 times our first term, which is 8, plus our nth term, which is 5 plus 3n. So we can simplify that a bit. N over 2 times 13 plus 3n. So now if we were asked something like find the sum of the first 10,000 terms of this, well, all we would have to do is plug in 10,000 for n. We can find out what that sum would be. All right, let's look at example 7. Here we're given a sequence. We have 60 plus 64 plus 68 plus 72 all the way up until we get to 120. So we have our first term, a sub 1, and our last term, a sub 1 is 60, a sub n, our last term is 120. But we need to find out what the n value should be. This is an n value of 1, 2, 3, 4. So what would this n value be? Well, let's return back to our nth term formula, which is a sub 1 plus n minus 1 times d. it looks like our common difference is 4, 60, 64, 68. So let's say a sub n, in this case it'll be 120, should be equal to our first term, which is 60, plus n minus 1, don't know what n is, times the common difference of 4. Now we can just solve for n. So we have 120 equals 60 plus 4n minus 4, or 120 equals 56 plus 4n. So then subtract the 56 over. Let's see what we get. 64 equals 4n, and then divide by 4. We get that n is equal to 16. So that is the 16th term that we're ending up on. So what we want to find is the sum up to an n value of 16. So in general, that's n over 2 times a sub 1 plus a sub n. So this should be 16 over 2 times our first term of 60 plus our last term of 120. So that looks like 8 times 180, which is 1,440. So if we know, and a key point here is that this only works for arithmetic sequences, but if we know that the sequence is arithmetic, then we can use this formula to find the sum of the first however many terms that we want to. So a pretty powerful tool. Okay, that'll be it for this video. So we saw how we can determine whether a sequence is arithmetic or not. We found general formula for an arithmetic sequence and the sum. So just to summarize, if the sequence is arithmetic, we can say a sub n is a sub 1 plus n minus 1 times d, and the sum of the first n terms is n over 2 times a sub 1 plus a sub n. Okay, that'll be it for this video, and I'll see you next time.